Hi everyone. So we're going to go ahead and cover today's topics, and we're back into exponents. We're going to be working, this is the last day we're working on exponents, and then we're going to go into polynomials our next class. But let's go ahead and take a look at some of the things that we're looking at, and some skills that we're going to be looking at today. These are the ways I like thinking about it. This is my personal way of looking at it. There is no right way, meaning that there's a lot of different ways of getting to the same answer. But this is the way I like looking at it to make things sort out nicely in my brain, because we're going to see a lot of exponents and a lot of negative signs. So let's look at our first one. So we're looking at negative exponents. And again, make sure you are taking notes. It does help your brain memorize this stuff and remember like these skills, okay? So we're going to do multiplication division with negative exponents. That's our first skill, and we're going to do another skill right after that. So here's my first one. If I say x to the negative 2 power times m to negative, x to negative 8 power times x to the 5th power. Okay, we have a couple ways of doing this problem. Let's do it based on our first rule. Our first rule is that if I am multiplying powers, I'm adding the exponents. That means I can actually add negative 2 plus negative 8 plus 5. Now, this is a rule. Okay, so since it's a rule, we can always run back to it. If I'm multiplying powers, just add the exponents no matter what they are. In this case, sure, there's negative. We can rewrite this as x to the negative 2 power minus 8, because a positive times a negative is a negative, plus 5. Combine those. Negative 2 and negative 8 becomes negative 10. Negative 10 plus 5. I have more negatives, x to the negative 5. To rewrite this, remember, negative exponents mean you don't belong here. Go on the denominator, 1 over x to the 5th. Okay, this is our classic algebra way of doing it. Would I say this is the best way? This is our rule-based way, and it works. It works 100%. And we want to make sure we know how to deal with multiplying powers. Now, I want to show you the way I like thinking about it, the way it works in my brain. First thing, what I do is I say, hey, look, negative exponents, you guys don't belong here. So I draw a fraction, and I say, you know what? You actually end up on the denominator, and you are both on bottom. X squared on bottom, and x to the 8 on bottom. Does x to the 5th go on the bottom? Nope. It's positive, so it stays where it's supposed to stay. So what I do is, instead, I like changing everyone to a positive exponent. That's the way I work it. I change everyone to a positive exponent. From here, we can say, well, don't we have 5 on top and 10 on bottom, because I'm adding 2 and 8? Now, there's two ways of looking at this now. One is the classic, I have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If we want to get rid of x's, we're going to divide x 1, 2, 3, 4, 5. These guys all cancel out. They all divide out to become 1. And we're left with 5 of them on the bottom. Now again, both of these ways are perfectly fine. They're just different ways of looking at the same thing. One is just keeping it as exponents. The other one is writing it out. Do not do this unless if you're stuck. But it is a way for us to go back to visually look at what we're doing. X divided by x is 1. So if I have 5 x's on top and 10 on the bottom, at least 5 of them would divide out to become 1. We would have 5 left on the bottom. Okay. Let's do another problem. If I give you x to the 0, x to the negative 4, x to the 7, okay, and then x to the negative 6. Okay, so we could combine them all. X to the 0 plus negative 4 plus 7 plus negative 6. Why? Because if I'm multiplying powers, I'm adding exponents. To relook at this, we have 0 minus 4 plus 7 minus 6. Looking here, that's negative 4, negative 6 is negative 10. Negative 10 plus 7 is negative 3. X to the negative 3 power. Okay, I'm just trying to find easy numbers to add together. Now again, if there's a lot of stuff going on, I can always rewrite this as a fraction. You end up here on the bottom, you end up on the bottom. And what's x to the 0? X to 0 is always 1. Now don't be afraid of writing 1, and we'll talk about that using our skills today. Why is it 1? So we have, draw the prime fraction, we have x to the negative 4th power on the bottom, and x to the 6th power. Please notice that I get rid of no negatives. Because once you move them to the other side, it's almost like your ticket to the movie theater. You give up your ticket. Well, you give up half of your ticket, right? And x to the 7 stays on top. What about the x to the 0? We said that becomes a 1, so we don't need to write it anymore. Now, how many x's do we have on the bottom? Well, again, if we're multiplying, we're adding. We have x to the 10. 4 plus 6 is 10. Now, you can start canceling them out. If I have 7 on top and 10 on the bottom, they're going to start canceling out. And I'm going to end up with 3 on the bottom, which is our same answer. So the more you do this, it's just like when you learn your multiplication tables. They just become second nature. And you want to make sure you practice these so they become second nature, so they won't be an obstacle. Now these problems, of course, can get a lot more confusing. And now let me give you one that looks a lot more confusing. Let's do x to the negative 1 times x to the 44 over x to the negative 5 times x to the 4th power. Okay, so we have x's everywhere, some positive, some negative. Okay, some positive, negative. Now, for me to get this sorted out, you could, again, multiply straight across, but instead, let's just move everyone to the other side of the fraction sign that has a negative. I'm going to kick you back to where you're from. Get out of my basement. Get out of my... Okay, so I'm going to kick them around because negative exponents means you don't belong here. And then I'm going to write that as a positive version because I moved it to the top. You don't belong here. Move it to the top. On the bottom, we have x is negative 1. We're going to move it to the bottom. Okay, and you can write a 1 there. You don't have to write a 1. Just remember, whenever you see a variable by itself, there is a 1 exponent on top. So how many do we have on top? We actually have 49 on top, right? 5 plus 44 is 49. We're multiplying 49 together. I don't want to multiply 49 together. So that's why we write the exponent. And on the bottom, we have 4 plus 1 is actually 5. Again, why is that? Just to show you, demonstrate 1 here, and I have 1, 2, 3, 4. We actually have a total of 5. That's why we're adding. We're not multiplying them, we're adding them together. Sorry about the squeak. Now, if I have 49 on top and 5 on bottom, we know they're going to cancel each other out. So we have a lot on top, and we have 44 left on top. Okay. You might have also noticed, isn't 5 and 5? And you could save your time and just divided those out, and you would still have been left with 44, saving a little bit of time. Okay, let's do another one of these crazy fraction ones. We have x to the negative 50 over x to the 0 times x to the 10 times x to the negative 1 power. Okay, a lot of stuff is going on. We got a lot of negative exponents. So the first thing I like doing is making everyone positive. Get back to your side. So you don't belong here. Get back to your side. Here we go. And we're going to move this guy up. So our fraction, we're going to have we're going to move the 50 to the bottom. Just a reminder, what is x to the 0 power? What's anything to the 0 power? That's going to be 1 for us. And then we have x to the 10. That is still stuck on bottom, right? Stuck on bottom. And you have to go on top. X on top. Okay, let me go ahead and draw some colors here so you guys can see what these numbers are related to. This one became this one down here. This guy stayed here. And one more, this guy went up. Okay. So we move them around based on their exponents. Okay, now how many do we have total? We have 1 on top and 60 on the bottom. They're going to cancel out. Now, here's a mistake that often kids will say. They'll say, oh, Miss Go, there's 59 left. Well, is the 59 on top or bottom? And probably you guys are screaming at me now. And then they're on the bottom. And that's perfectly fine. Okay, so leave them on the bottom. Now, I want to go over the rule real quick. Why is x to the 0 power 1? Why is x to the 0 power 1? If I tell you x squared divided by x squared, you would be okay to say x squared divided by x squared is equal to 1. It's x times x over x times x, and they would divide out to become 1, right? Okay. But let's do this a different way. I want to write this out as negative exponents. We can rewrite this as x to the negative 2 power times x squared. Are you guys okay with me moving up the fraction on top? Remember, if we move something in the fraction and the denominator up to the numerator, we want to put a negative exponent to that. A negative exponent to that. Now, what am I doing when I'm multiplying powers? I'm adding them. So x to the negative 2 plus 2. What's negative 2 plus 2? That's x to the 0. And what did we say x squared divided by x squared is? It's 1, and that's what this also equals to. It equals to 1. Okay. So when we have a variable or a number or anything to the 0 power, we just call that 1 instead. The example is here, x squared divided by x squared. That would have been x to the 0 power, and we said x squared divided by x squared is 1. Okay, now I'm going to do one problem back to what we were talking about before. This is going to be a crazy one. A7 b squared c0 d0 over a to the 8 b to the negative 1 c to the negative 1 d to the negative 6 times a to the negative 1 b to the 8 c to the negative 7 and d to the negative 1. So everyone's multiplying by everyone here, and this looks like a crazy party that got out of control. You got people upstairs, you got people downstairs. People on downstairs shouldn't be there, they should be actually upstairs. So we're going to move these around first to simplify the problem. First thing I want you guys to notice, are there any zeros to 0 power? 0 power? 0 power. Okay, so we don't have to write those anymore, because what's anything to 0 power? That's 1. We got some negatives here. Let's go ahead and get rid of these negatives. I need to move you, and you. These guys have to be moved. They're actually on the wrong side of the problem. Let's go ahead and rewrite this. A7, A7, b squared. Okay, let's start moving stuff around. I have a to the 8 on the bottom. That b1 needs to go on top. That c1 needs to go on top. And that d to the negative 6 needs to go on top. That a needs to go on top. That b needs to stay on the bottom. And that c goes on top. And that d goes on top. Wow, we moved a lot of people up, right? We moved our B, oh darn it, wrong sheet. B, C, D, A, C, and D. We moved them all up. And if you notice, please remember, you don't write the negative signs once you move them to the other side. Now let's go ahead and combine our common bases. So I'll color these B, B, okay? We have a C, C, we have a D, D, and we have a A, A. Okay, I'm colorblind. Hopefully you guys don't get confused by color. I do, but I'm writing in case you guys find it helpful. Let's rewrite this. We have A, that looks like a 9. So our fraction, we have A, 7 and 1 make 8 on top because we're adding them. B squared is B to the 4th. C1 and C7 is C to the 8. D6 and D1 is D to the 7. And we have A8, B8. Sure, we're writing this a couple of times. This is a large problem. It's okay. Large problems, you should be able to write a lot. Now, we're going to start dividing them. A8, oops, please notice, A8, A8. These are going to cancel out. We have B's. I have more B's on the bottom. Okay, how many more do we have on bottom? So we have B, nope. We have 4 more on the bottom. So we have C8, D7 over B to the 4th. And that's what we have left. And we did this because if I divided A8 by A8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. They would have all canceled out and became 1. Lost the other one. Okay, they all have become 1. That's why we don't have to write them anymore. Another way of looking at it, A8 divided by A8 is A8 minus 8, because if we're dividing, we're subtracting. A to the 0 is 1. Okay, there's like 3 different ways for us to look at these exponents when I'm combining them. Okay, let's go through our next rule today, or our next task, is we're just gonna, so far we've been using variables a lot. Now today what we're going to do, we're going to actually just use numbers on our second task. And the task is, what happens when I do multiply 4 squared times 4 cubed? Okay, 4 squared times 4 cubed. How many 4s do we have? We have 4 to the 2 plus 3, and you can write 4 to the 5. Please just write 4 to the 5. Just skip from here to here. That's perfectly fine. But you should be understanding I'm adding them. If you're not sure, if you forget, again, this could be a couple weeks, and then you might forget. You have to remind yourself, I have 2 4s here, and I have 3 4s here. So how many 4s do we have? Michiko, we have 6 4s. No, we don't. We don't have 6 4s. We have 5 of them. Okay. Now this is a simple way of reminding yourself, and I do this sometimes. Like if I forget something, I go back to the super basics. Super basics. Let's not think of these as exponents. Let's think of these as just multiplying each other. Now, on your calculator, you're going to actually type that out. What is that going to be? So let me go ahead and share my screen, share my calculator. Hi, calculator. And I'm going to take 4. I'm going to clear this one. 4. Come on, 4. And then, if you notice here, I have an XY button. You all see the XY? That's a base and exponent. I'm going to XY. 4xy 5 equals, and my answer is 1024. Okay, 1024. If you have a calculator and you're not sure how to use it, go ahead and try it right now. If you don't have this XY button, look around. If you don't have the XY button, you might have something that says a caret. If you have a little symbol that looks like a triangle, half triangle, type this instead, and you should end up with the same answer. So why don't you guys spend a couple seconds there and try looking for a calculator and looking for these buttons. If you don't have any of these buttons, please let me know. Or you can send me a picture of your calculator. Just take a picture of your calculator and I'll tell you which button you can use. Okay. Sometimes calculators will use AB for a to the b power 5. That is another way of representing these numbers, depending on the calculator you have. Casio, TI, generic 99-cent store one. Okay, so most of our work today will be on this calculator after we have rewritten the problem. Okay, let's look at another problem. We have 3 squared times 5 squared. Okay. Now, for this problem here, go ahead and there's nothing to combine here. We're just 3 and 5. So this is really 9 times 25. But on your calculator, you could just type it in as you see it. You could say 3 squared times 5 squared equals, and see if you get 225. And 9 times 25 is 225. And unfortunately, I count quarters. That's 1, 2, 3, 4 quarters, 5, 6, 7, 8 quarters. 9 quarters is $2.25. Cha-ching. Sorry, that's how I count quarters, which is 225. But you want to make sure you know how to use your calculators. The calculators require you to write certain things in certain orders. Now, just FYI, there is a square button here to make life a lot easier for everyone. And there's a cube button because these are the most popular buttons that we use. But of course, if we don't have square or cube, you can use the X to the Y button for anything bigger than a cube. Again, take a look at your calculator if you do have these buttons. Now, this next problem here, it's going to take us a little bit of work before we even use our calculators. Now, what do we say about these negative exponents for this problem? Do they belong here? Nope. So let's move them. Where do these negative exponents go? 5 actually goes on the bottom. So sorry, this is fourth power, if you guys didn't probably know already. So we're going to say 5 squared and 2 to the fourth power. And remember, once we move something out, we still have to put an invisible 1 there, because it still is a fraction. So on your calculator, we're going to write 1 over, we're going to say 5 squared times 2 exponent xy, right, xy, 4 equals, and we should end up with the number 400. Go ahead and try that on your calculators to make sure you are getting the same number. So I'm doing the top separate from the bottom. Okay, once I simplify, I'm going to do the top separately from the bottom. And if you don't have a calculator, you can download one on your phone. I'm not talking about photo math. I'm actually talking about using a calculator. If you guys have an iPhone, you might want to change that to scientific. Okay. This calculator, I think I downloaded it. Oops, they want me to pay. They want me to pay 99 cents a month? What? Everyone's going to these yearly, monthly. It's for continued revenue. I don't like it. I like paying one time and leave me alone. Okay, here's my next problem here. So this next problem looks a little messy because of all these negative exponents. Let's just move them in a fraction to where should they be. Okay, the fraction. The 2 here is negative, so we know it's going to be on the bottom. The 9 is positive, so we're going to stay on top. And the 9 to the 8, negative 8, that's going to be on the bottom. And I'll write that as a positive exponent once I moved it. Right? So where do you belong? You belong on the bottom, and you belong on the bottom, and you, sir, 9 to 9, you're on top. All right. So now it's just calculator work. 9 to the 9, 9 to 9 is a huge number. Oh my goodness, you're kidding me. And 9 to the 8. Oh my goodness, are you kidding me? You want me to write this number? But couldn't we simplify this first? Hey, I have 9 9s on top and 8 9s on the bottom. They should divide out. That's a huge number. And the point is that we don't want that huge number. We want to simplify first. So the 9s on top and the 9s on the bottom would cancel out, leaving me just 1 9 on top and a 2 on the bottom. Because this would be 2 times 1. That would just be 2. So much easier to write. The answer is just 9 over 2. So the idea is once we get everyone on their correct corner, then if we could simplify the problem, please simplify the problem. Okay, let's do one more. We'll say 4 to the 5th power times 4 to the negative 8 times 4 to the 7. So hopefully you're seeing that the negative exponent, you don't belong here. Okay, you gotta move. Here we go. We're gonna have 4 to the 5th times 4 to the 7th over 4 to the 8th. And if you want, you could have jumped from here to say, hey, 5 and 7, that's 4 to the 12th over 4 to the 8. You could have done that. That's perfectly fine. Well, again, we said this is 4 to the 12 over 4 to the 8. Can we simplify? Can we get rid of some of these 4s? Yeah. We have more 4s on top. So we have 4 to the 4 on top, and we have nothing on the bottom. You don't have to write that fraction as a 1 anymore, okay? You don't have to. Our answer is 4 to the 4. Because 12 minus 8, remember if we're dividing, we subtract exponents. 4 to the 12 minus 8 is 4. Okay, now on the calculator, 4 to the 4th power is 256. That's right, 256. Okay, that's it.